Welcome to this simple tutorial on how to program a neuron from scratch. It requires no previous programming knowledge and only basic math skills. If you have never used Python before, then I recommend that you simply open a notebook in Google Colab. There's a link in the description. First off, what is a neuron? It's an artificial brain cell that the AI uses to predict answers, and it's very often part of a greater neural network. It consists of inputs where the AI receives information, and then hidden layers where it does its math in secret, and eventually the output layer where it tells the user the answer it arrived at. The neuron that we're creating today is known as a perceptron. It has two inputs and a single output neuron. We will then use it to solve logic gates, which are a fundamental component in computer science, which takes in binary numbers and returns binary numbers according to the logic. Two fundamental logic gates are the AND gate. If the first input and the second input is 1, then it returns 1. But if any of the inputs are 0, then it returns 0. It's called an AND gate because both the first and the second input must be 1 for it to return 1. And then we have the OR gate. The OR gate is called that because any of its inputs can be 1 for it to return 1. The first input or the second input or both inputs can be 1. Let's start our first code block by defining our data set. We do this simply by writing data equals and then square brackets to create a list, and in that list we will have 4 tuples where each tuple will consist of 3 numbers. The first tuple will be 0, 0, 0, then 1, 0, 0, and 0, 1, 0, and finally 1, 1, 1. Now looking at this, can you tell what it is? It is the AND gate. The first two columns are the inputs and the final column is the output. And as you can see, it's only when both inputs are 1 that the output is 1. Create a new code block by clicking the plus code button. Now we initialize the weights and biases and the learning rate. We call the weights weight 1 and weight 2, and for this exercise we set the weights and the bias to 0.00 and the learning rate to 0.1. The weights can be thought of as the tuning between neurons, while the bias is the tuning of the neuron itself. In the same way that you would tune a guitar up or down to get the right pitch, you tune the weights and biases to get the right answer. Now create a new code block. And here we put in the rest of the code. So if you want to, you can just write it down from the screen right now, but I'm also gonna go through it line by line. And then afterwards, I'm also going to demonstrate what the code actually does. So we start by defining a step function by writing def step and in parentheses x. This returns the number 1 if x is 0 or greater, else it returns 0. Under that we create a neuron function which takes the parameters input 1 and input 2, and it returns the step function with the equation input 1 times weight 1 plus input 2 times weight 2 plus bias. After that we write for epoch in range 5, which is a loop that will repeat the code beneath it 5 times in total. Under that we write another loop called for input 1, input 2, output in data, which will loop through the tuples in our data set. Under that we have prediction equals neuron input 1 and input 2, which returns the neuron's prediction. Under that there's error. It's often known as a delta, or how wrong the model was, but for ease of understanding I've called it error here. Error equals output minus prediction. And then afterwards we adjust the weights by weight 1 plus equals learning rate times error times input 1, and then we do the same for weight 2 except with input 2. And then finally we adjust the bias with the learning rate times error. Under that we write print f, and in the quotation marks we write what we want the print function to return to us. All the things that are inside curly brackets will return the value of the variable inside the curly bracket. I've written 2 print lines here simply to get everything on screen, but you can do all of this in a single line. And now your code is ready to run, so you can just run it if you want to and see what happens. However, I will also explain what is going on. So in our line for input 1, input 2, output in data, it looks at the data list we created, and then it assigns these variables to their respective column in the data set. So the first column becomes input 1, the second becomes input 2, and the final column becomes output. And then it loops through every tuple in the data set and sends it to the code beneath. Then prediction returns the neuron function with the value of input 1 and input 2, which of course activates the step function. And since in the first round everything is 0, the equation simply becomes 0 times 0 plus 0 times 0 plus 0, which activates the step function with the argument 0. And since 0 is 0 or greater, it therefore returns 1 to the neuron function, which returns 1 to the prediction. And since the correct answer here was actually 0, we take output minus prediction, and our error becomes -1. Then our weights get adjusted by learning rate, 0.1 times error -1 times their inputs. And here is where we run into our first problem. The inputs are 0, and if we multiply anything by 0, you get 0. So nothing actually gets updated in this round until we get to the bias. Because the bias is independent of any input, so it simply takes the learning rate times error, and it adjusts itself to -0.1. And then everything gets printed on screen. Now I'll quickly summarize the most important things that happen next. As all we have is a negative bias, it will continue to return 0 on the next tuples, which are correct, until it arrives at the final tuple where the correct answer is 1. And this causes the bias to be adjusted back up to 0, but our weights are now adjusted up to 0.1 because they're no longer being multiplied by 0, so this time they do in fact change. Then in the next round it will guess 1 again on the first tuple, and then also guess 1 on the second tuple. And then it will be adjusted down again. But since the first input in the second tuple is 1 and not 0, this time weight 1 gets adjusted down, but weight 2 doesn't. Which means that our two weights are now different from each other. They can then specialize, and in a total of 4 epochs, they will have solved the AND gate. Now, if you want to try the same thing again except solving the OR gate, then you simply have to change the outputs in data to reflect the logic of the OR gate, and then run the data block again. You can also reset the weights and biases by running that block as well. That's the benefit of having separate blocks, is that you can run them individually and therefore restart code without changing previous variables that belong to another block. And congratulations, you have just created your first neuron. There are 2 other logic gates you can solve with this. One is the NAND gate, which is the exact opposite of the AND gate, and returns 0 when both inputs are 1, and otherwise returns 1. And then there's the NOR gate, negative OR, which is the opposite of OR. However, our neuron will not be able to solve a gate like XOR or exclusive OR that returns 0 if both inputs are 0 or 1, and only returns 1 if the inputs are different from each other. Can you think of why? One way of explaining this is that in the previous logic gates, there is a shift where the output goes from 0 to 1 and stays there, or from 1 to 0 and stays there. While with the exclusive OR gate, it goes from 0 to 1 and 0 again. That means that there are technically 2 cutoff points here. One way to think of it is that the exclusive OR gate has its own AND logic. If the sum of inputs are greater than 0 and less than 2, then the output is 1. If you want a better, more visual explanation of this, Welsh Labs has an amazing video where he displays this using an actual grid. His videos are high quality, in depth, and he puts in an amazing amount of effort in every single video, so I really recommend his channel if you want to learn and understand more. If you want to solve exclusive OR, you're gonna need a network with 2 hidden neurons. And I can make a tutorial on how to do that if there is demand for it, but it is significantly more difficult. However, I will upload a notebook to both GitHub, Kaggle, and Google Colab, where I have created both the neuron that we've done in this exercise as well as separate code blocks for this kind of neural network where there are two hidden neurons. I have separated this network into separate blocks that use different activation functions. The activation functions can be thought of as the math that the neuron uses to solve problems. This notebook also uses matplotlib to plot out what is happening as the neurons learn. It's much easier to understand what's happening when you have lots of numbers if they get visualized rather than trying to read them in text. You can also add more entries to the dataset and even teach the neural network to perform addition. The notebook is set up so that when you add more fields to the dataset, the AI's prediction to that entry gets added as its own plot in matplotlib. The notebook contains more instructions on how to use it. Also, I've mainly been using the notebook for experimentation, so it may be a bit buggy and the code could probably be cleaned up, so if you want to do that, feel free to do that. And also, if you enjoyed this video, please subscribe to my channel and to my Patreon. It will absolutely encourage me to make more videos in the future, and let me know if you have any requests. Thank you for watching.